Hello, and a very warm welcome to this quiet place, a space for gentle stories to accompany you into a peaceful and restorative sleep. Tonight, we will begin a long and soothing journey together, drifting out from the familiar shores of our world to wander among the silent, luminous islands of the cosmos. We will travel on the softest currents of thought, exploring the grand and tranquil story of our universe. Before we set forth on our voyage among the galaxies, I would be so deeply grateful if you would share in the comments where you are listening from tonight, or perhaps a gentle thought about your day. Your presence here helps to build this calm community. And if you feel so moved, please support our journey by liking this story and subscribing to the channel. Thank you so much for being here. Now, find a comfortable position, allow your body to feel heavy and supported, and let your breath slow to a gentle, easy rhythm. Our story begins now. Let us begin our journey in a familiar and quiet place, perhaps a soft field of grass on a clear and moonless night, far away from the glowing haze of cities. The air is cool and still, carrying the faint, sweet scent of the sleeping earth. As you rest here, feeling the solidness of the world beneath you, allow your gaze to drift upward, past the dark silhouettes of trees, and into the deep, unending velvet of the night sky. There they are, countless points of light, scattered like spilled diamonds on a cloth of infinite black. Some shine with a fierce, unwavering brightness, while others offer a softer, more delicate glimmer. And as you watch them, you may notice that they do not simply sit there, static and cold. They shimmer, they pulse. They seem to tremble with a silent, ancient life. This gentle twinkling, this soft and restless dance of light, is a story that begins not in the distant heart of a star, but right here, in the final moments of its long journey, just above our heads. For between us and that vast emptiness lies our atmosphere, the deep and invisible ocean of air that blankets our world. This blanket is our shield, our life-giver, a swirling, ever-moving current of nitrogen and oxygen, warmth and wind. The light from those distant stars, having travelled unimpeded for years, for centuries, for millennia across the perfect vacuum of space, finally enters this ocean of air, and in its very last second, its journey becomes a dance. It is jostled and nudged, bent and refracted by the moving pockets of warm and cool air, its perfect, straight path now a shivering, wavering line. And so, what we see as a twinkle is the final breath of an ancient journey, a story of light being gently caressed and altered by the very air we breathe. It is a beautiful reminder that we are not separate from the cosmos. Looking out through a sterile window, we are submerged within it, looking up from the bottom of a gentle, life-giving sea, and the sky's performance is for us alone. As we continue to gaze at this shimmering tapestry, our minds naturally begin to wonder about the distance to these lights. Our human experience gives us measures for the world we know, an arm's length, a stone's throw, the horizon on a clear day. But these scales fail us here. To speak of the space between stars in kilometers or miles is to try and measure an ocean with a thimble. The numbers become so vast they lose all meaning. And so, astronomers conceived of a more poetic, more truthful measure, one that embraces the very essence of what we are seeing. They measure the universe in light years. A light year is not a measure of time, but a measure of distance. Yet it is a distance defined by time. It is the distance that a beam of light, the fastest thing in the universe, can travel in one full terrestrial year. 9.46 trillion kilometers of silent, uninterrupted flight. To think in light years is to change our perception of the cosmos. It is no longer just a space to be crossed, but a story to be read. Each light year is a chapter, a volume of silent travel. When we say that a star is 100 light years away, we are saying that the light touching our eyes tonight began its journey 100 years ago, when the world was a different place. The light itself has become the storyteller, a messenger carrying a tale across the void. With this understanding, the night sky transforms. It is no longer a static portrait of a single moment in time. It is a living museum, a gallery of ancient histories, all layered upon one another in the endless depth of the sky. The light from the very nearest star to our own sun, Proxima Centauri, a faint red jewel in the southern sky, began its journey to you 4.24 years ago. The light you see tonight left that star while you were living a different chapter of your own life. When you look at Sirius, the brilliant blue-white dog star that shines so brightly in the winter sky, you are seeing light that is 8.6 years old. It began its voyage when the child, who is now a teenager, was just beginning to walk. And this is just our closest neighborhood. The beautiful constellation of Orion, with the bright star Betelgeuse at its shoulder, sends us light that is over 640 years old. That shimmer you see tonight is an echo from the Middle Ages on Earth. And the great Andromeda galaxy, a faint, fuzzy patch of light just visible to the naked eye on the clearest of nights, is a ghost of light that has been traveling for 2.5 million years. The light that graces your retina from that distant island of stars began its journey when our earliest human ancestors were first walking the Earth. The sky, then, is a deep well of time. Every glance upward is a form of time travel, a communion with the past, a silent acknowledgement of the immense and patient story of the universe. As your eyes drift across this cosmic sea of time, they may settle upon our closest and most constant companion, the moon. Unlike the distant stars, the moon does not twinkle. It hangs in the sky with a calm, steady, and silent grace. Its light is soft, a borrowed glow, a gentle reflection of the sun's fire, tamed and cooled by its journey to the lunar surface and then back to us. The moon feels different. It feels like part of our world, a silent guardian in a permanent, loving embrace. And in a way, it is. For the moon is locked in a slow, patient dance with the Earth, a dance orchestrated by gravity over billions of years. It is tidally locked, meaning it rotates on its axis in the exact same amount of time it takes to orbit our planet. The result of this perfect synchrony is that it always shows us the same face, the same familiar pattern of ancient, dark seas of basalt and bright, cratered highlands. We've only ever known this one side of our companion. This gravitational lock is the result of a long and gentle conversation between two celestial bodies. The Earth's gravity pulled on the moon, creating a slight bulge, and over eons, that pull slowed the moon's once faster spin until it settled into this perfect, stable rhythm. It is a quiet testament to the power of patience and persistence, a relationship written in the slow, inexorable language of gravity. Its steady presence is a comfort, an anchor in the vast, shimmering sea of distant, ancient suns. It reminds us that even in the face of incomprehensible distances and times, we have a home, a starting point, a shore from which we can gaze out and wonder. This is where our journey begins, here on the shore of a cosmic ocean, with the ancient light of history washing over us, and our faithful moon standing silent watch. The soft, silvery light of the moon is a memory of sunlight, a gentle echo that allows our eyes to find rest in the darkness. And it is to the source of this light that our journey now turns. As our minds drift away from the Earth and its constant companion, we are drawn across the silent expanse towards the heart of our own celestial family, the sun. From our vantage point here on Earth, we must shield our eyes from its brilliance, and we feel its energy as a vibrant, sometimes harsh, warmth on our skin. But from the quiet perspective of sleep and gentle thought, we can imagine it differently. Let us visualize the sun not as a raging inferno, but as the calm, breathing center of our solar system, a sphere of incandescent grace. It is a star of remarkable stability, a vast globe composed almost entirely of the two simplest elements, hydrogen and helium. Deep within its core, the pressures and temperatures are so immense that the very fabric of matter is transformed. In a process called nuclear fusion, hydrogen atoms are gently but relentlessly pressed together, fusing to become helium. This act of creation, this merging of simple atoms into something new, releases a whisper of matter as pure energy, an unimaginable flood of light and warmth. This is the sun's heartbeat. It is a process that has continued with serene consistency for 4.6 billion years. And it is this steady, reliable pulse of energy that radiates outward in all directions, a constant and life-giving embrace that crosses 150 million kilometers of cold, empty space to warm our world, to power our weather, and to fuel every leaf, every flower, every living thing. It is the gentle, creative engine of our world, the ultimate source of the moonlight's borrowed glow and the life in our own veins. This great, luminous heart holds our entire solar system together in a delicate and predictable ballet, and it does so with an invisible, silent force. This force is gravity. We often think of gravity as a pull, something that yanks objects downwards, but the reality is far more elegant, more wondrous. The great mind of Albert Einstein imagined gravity as a curvature, a gentle depression in the very fabric of reality, which he called space-time. Imagine a vast, flat sheet of fabric stretched taut. If you place a heavy ball in the center, it creates a dip, a gentle, sloping well. The sun, with its immense mass, does the same thing to the fabric of space-time. It creates a vast, sloping valley in the cosmos. The planets, our Earth included, are not being violently pulled towards the sun. Rather, they are following the smooth, curved paths within this valley. They are like marbles rolling along the edge of a great, invisible bowl, held in a perpetual, graceful orbit by the very shape of the space they inhabit. These invisible threads of gravity, these gentle contours of space-time, are what bind our cosmic family together. They are threads of connection that are both powerful enough to hold giant worlds in their sway, and yet gentle enough to allow for the slow, predictable waltz of the planets, a cosmic dance that has been unfolding in perfect, silent rhythm for billions of years. It is a system of profound and beautiful order, a quiet testament to the simple, elegant laws that govern the universe, holding us all in its gentle, invisible embrace. As we drift along these curved pathways of space-time, we can begin our slow journey outwards, visiting the other members of our sun-blessed family. Closest to the heart of the system, we find the small rocky worlds, the terrestrial planets, huddled near the warmth. There is Mercury, a tiny, sun-scorched world of craters and extreme temperatures. Then Venus, shrouded in a thick, toxic atmosphere, a world of immense pressure and heat, a beautiful but inhospitable sibling. Then there is our own home, Earth, a perfect blue and white jewel of liquid water, temperate climate, and abundant life, existing in a delicate and precious balance. And just beyond us lies Mars, the red planet, a world of rusty dust, deep canyons, and towering, extinct volcanoes, holding the frozen memory of ancient rivers and perhaps the faintest possibility of past life. These are the inner worlds, the dense, solid foundations of the family. As we drift further out, beyond the great asteroid belt, we enter the realm of the giants. Here, the planets are of a different nature entirely. Jupiter, a colossal ball of gas more massive than all the other planets combined, a world of swirling, stormy clouds, and a great red spot that has been raging for centuries. Then comes Saturn, the jewel of the solar system, defined by its breathtaking and intricate system of rings, a vast, spinning disk of ice and rock, thinner than a sheet of paper in proportion to its size. Drifting further still, we meet the ice giants, Uranus and Neptune, two beautiful, blue-hued worlds of extreme cold, their atmospheres rich with methane, spinning silently in the distant, dim twilight of the outer solar system. Each planet is a world unto itself, a unique character in this grand family portrait, all born from the same swirling cloud of dust and gas, all bound by the same invisible threads of gravity, all bathed in the same gentle, distant light of their parent star. Our journey through this celestial family brings us to its very edge, where the sun's light is a faint and distant memory. And it is here, in the cold and the dark, that we encounter two of humanity's most hopeful and poignant creations, the Voyager probes. Launched in the 1970s, these two small, intrepid spacecraft have journeyed farther than any other object made by human hands. They are now drifting through interstellar space, having left the sun's gentle embrace far behind. They are our silent messengers, our scouts sent into the great, unknown ocean. Bolted to the side of each of these probes is a simple, golden phonograph record. This golden record is a message in a bottle, a collection of sounds and images from our world, curated to tell the story of who we are. It carries the sound of wind and rain, the songs of birds and whales, the music of Bach and Chuck Berry, and greetings in 55 human languages. It is a story of our world's beauty, our art, our science, and our hope. These little emissaries, powered by the slow decay of plutonium, will wander the Milky Way galaxy for millions, perhaps billions, of years, long after we are gone. They are a testament to our curiosity, our deep-seated need to reach out, to connect, to say, "We were here. This was our home. It was beautiful." And so, as we settle into the deep comfort of approaching sleep, we can imagine these two tiny specks of human creation, carrying our peaceful greetings as they drift ever onward into the profound and endless quiet, leaving the story of our solar system far behind. Our thoughts drift now with those two tiny messengers, the Voyager probes, as they journey ever onward, leaving the familiar family of planets to become silent specks in an ever-widening darkness. As they travel, they are approaching a boundary, though it is not a wall or a line that one can see. It is a vast, invisible sphere of influence, a magnetic bubble blown by our sun into the space between the stars. This is the heliosphere. For billions of years, the sun has been breathing out a continuous stream of charged particles, a solar wind that flows outward in all directions at 1,000,000 miles per hour. This wind carves out a great cavity in the thin gas of the interstellar medium, creating a protected cocoon around our entire solar system. Inside this bubble is the realm of the sun. Outside is the great wilderness of the galaxy. The edge of this bubble, the heliopause, is the place where the sun's outward breath finally grows tired, where its pressure meets and balances with the gentle, persistent pressure of the interstellar winds. In 2012, Voyager 1, after 35 years of travel, quietly slipped across this boundary. The data it sent back told of a serene transition, a moment of profound change where the magnetic field shifted direction and the hiss of solar particles was replaced by the low hum of cosmic rays from distant, exploded stars. Crossing this threshold is like a ship sailing out of a river's mouth and into the open ocean. The currents change, the water feels different, and the familiar shores of home recede into a distant memory. Our solar system is a sheltered harbour, and the heliosphere is the invisible breakwater that protects us from the harsh, energetic waves of the galactic sea. As we drift conceptually beyond this magnetic veil, we encounter another, even grander and more mysterious boundary of our home. This is the Oort cloud, a theoretical, immense sphere of icy bodies that is believed to encircle our solar system at a truly staggering distance. It is not something we have ever seen, nor can we see it. It is a ghost, a whisper, a hypothesis born from the careful study of comets. We have noticed that many comets, those beautiful, long-tailed visitors to our inner solar system, arrive from all directions in space on orbits that take thousands or even millions of years to complete. This suggests they come from a vast, spherical reservoir of primordial material, a dark and distant halo of frozen remnants from the birth of our solar system 4.6 billion years ago. Imagine an immense, dark sphere, so vast that light would take more than a year to cross it. Within this sphere, trillions of icy bodies, some the size of mountains, others as large as minor planets, drift in a state of near-perfect stillness and cold. They are the unused building blocks of our planetary family, tossed outward in the chaotic early days of the solar system's formation. Here, in the profound darkness, they wait patiently, held in the sun's faint and tenuous gravitational grip. Every now and then, the gentle gravitational nudge from a passing star, or a subtle tide within the galaxy itself, might disturb one of these silent wanderers, sending it on a slow, patient, 10,000-year journey inward, to grace our skies as a fleeting, luminous comet. The Oort cloud is the true, grand attic of our solar system, a silent, dark museum of our origins, reminding us that the full extent of our home is far greater and far more mysterious than we can ever hope to see. Having drifted in our minds past the solar wind's reach and through this ghostly sphere of comets, we finally arrive in the space between the stars. This is interstellar space. The word space itself suggests emptiness, a void, a nothingness. and in human terms, it is almost incomprehensibly empty. Here, the density of matter drops to a few atoms per cubic centimeter, a vacuum far more perfect than anything we can create on Earth. The silence is absolute, a quiet so deep that it is not the absence of sound, but a presence in itself. The temperature hovers at just a few degrees above absolute zero, the theoretical point at which all motion ceases. But this great expanse is not truly empty. It is filled with a thin, ethereal mist of hydrogen and helium gas, sprinkled with tiny grains of dust made of carbon and silicates. It is crisscrossed by the faint, ancient light of distant stars and permeated by invisible magnetic fields that drift and flow like slow, cosmic currents. To be here is to understand the true scale of the cosmos. The stars, which from Earth appear to be scattered closely on a two-dimensional dome, are revealed to be incredibly isolated islands of light separated by unimaginable gulfs of this dark, quiet, and cold emptiness. This space is the great, calm ocean of the galaxy, and to journey through it is to feel a sense of peace that comes from immense scale, a tranquility born of the knowledge that all the urgency and noise of our world is but a tiny, fleeting whisper in a vast and silent cathedral. From this vantage point, suspended in the quiet darkness of the interstellar ocean, we can turn our gaze toward our final destination, our grand, celestial home, the Milky Way. From the inside, as we see it from Earth, it is a faint, cloud-like band of light stretching across the night sky, a luminous river that gave our galaxy its name. But from out here, its true form would be revealed. We would see a vast, spinning disk of light, a celestial pinwheel of breathtaking beauty and scale. Our sun, our Earth, our entire solar system is but one of 100 billion stars, or perhaps more, that constitute this immense island in the cosmos. We are not in the center, nor on the edge. We reside in a quiet, peaceful suburb of this grand galactic city, nestled within one of its graceful, curving spiral arms, the Orion Arm. Our position is a fortunate one. Far from the chaotic and brilliant glare of the galactic core, a safe distance from the powerful radiation and gravitational turbulence that characterize the galaxy's bustling center, we are living in a calm, gentle eddy of this great, luminous river. And as we float here, in the quiet space just beyond our home system, we can take a moment to simply behold it. This is our home on the grandest of scales, a swirling, self-contained universe of stars, gas, dust, and mystery. And our journey is about to take us deep into its heart, to drift along its luminous currents and explore the wonders held within. Having crossed the quiet, dark ocean that separates our solar system from its neighbors, we now drift gently into the embrace of our home galaxy, the Milky Way. We are no longer observing it from afar, but are now a part of its majestic, swirling dance. Imagine yourself suspended within this luminous river of stars, a single, conscious mote of dust in a structure of unimaginable grandeur. The galaxy is a vast, rotating disk, a flattened city of stars 100,000 light-years from edge to edge. At its heart is a dense, glowing sphere of light known as the central bulge. This is the Old City, a tightly packed hub of ancient, golden-hued stars that have been circling the core for billions of years. Their orbits a chaotic and beautiful swarm, like bees around a hive. Radiating out from this brilliant core are the great spiral arms, the feature that gives our galaxy its iconic shape. These arms are not solid structures, but are more like celestial traffic jams, slow-moving waves of density where gas and dust are compressed, triggering furious bursts of new star formation. These are the bright, bustling suburbs of the galaxy, painted with the brilliant, blue-white light of young, hot stars. And enveloping this entire luminous disk is a vast, faint, and ghostly sphere called the halo. This is the galaxy's ancient attic, home to scattered, ancient stars and globular clusters, the very first structures to form in the Milky Way's history, along with an even greater and more mysterious sphere of invisible dark matter, which provides the gravitational scaffolding that holds our entire, beautiful galaxy together. To drift here is to be held within a living, breathing system of profound and intricate order. let us guide our drifting thoughts into one of these vibrant, luminous spiral arms, the very same arm that our own sun calls home. Here, between the established stars, we find the galaxy's stellar nurseries, the places where new suns are being born right now. These are the great nebulae, clouds of interstellar gas and dust, so vast that they can stretch for hundreds of light years. They are not dark, formless voids. They are cosmic canvases of breathtaking colour and light. The most common element in the universe, hydrogen, when energized by the light of nearby newborn stars, glows with a deep and soulful red. Oxygen, in the same way, radiates a soft, ethereal blue-green. Sulfur shines with hues of orange and yellow. Within these clouds, painted with the elemental colors of the cosmos, gravity begins its slow and patient work. Denser pockets of gas and dust begin to pull inward, drawing more and more material toward their center. These clumps grow hotter and denser over millions of years, collapsing under their own immense weight, until the core becomes so hot and so pressurized that the spark of nuclear fusion ignites. A star is born. This new sun then blows away the remaining gas and dust around it, revealing itself and its nascent family of planets to the galaxy. These nebulae are places of gentle but powerful creation, cosmic wombs where the dust of old, dead stars is recycled into new light and new worlds. They are a tranquil reminder that our galaxy is not a static museum piece, but a dynamic, ever-changing place of birth, life, and renewal. From these gentle places of creation in the outer arms, let us allow our journey to follow the luminous currents of stars as they flow inward, toward the powerful and mysterious heart of our galaxy. The closer we get to the galactic center, the more densely packed the stars become. The quiet, spacious neighborhood of our own sun gives way to a brilliant, dazzling metropolis. Here, millions of stars are crammed into a space only a few light years across, all circling a single, unseen point with incredible speed. They swarm and orbit in a frantic, gravitational dance around the very center of the Milky Way. And at that exact center lies one of the universe's most enigmatic objects, Sagittarius A star, our galaxy's supermassive black hole. We must not imagine this as a cosmic monster, a terrifying void that consumes everything in its path. Instead, let us see it as the quiet, gravitational anchor of our galaxy. It is 4 million times more massive than our Sun, an object of such immense density that its gravity shapes the orbits of all the stars in the galactic core and, to a lesser extent, everything else in the galaxy, including our own distant solar system. It is the silent, heavy heart around which the entire, luminous pinwheel of the Milky Way pirouettes in a slow, majestic orbit. Our Sun, with our Earth in tow, takes roughly 230 million years to complete just one of these grand circuits. This is our galactic year. It is a timescale so vast it humbles all of human history, a slow, deep rhythm that connects us to the very center of our stellar home. As we rest here, suspended in this vast city of stars, it is peaceful to reflect on its sheer, mind-altering scale. 100,000 light-years across. If you were to shrink our entire solar system out to the orbit of Neptune, down to the size of a single grain of sand, the Milky Way galaxy would be a shimmering, sandy beach stretching for more than 10 kilometers. Our Sun is just one of hundreds of billions of stars in this single galaxy, and the galaxy itself is just one of hundreds of billions, perhaps trillions, of galaxies in the observable universe. To contemplate this scale is not to feel small or insignificant, but to feel connected to something immeasurably vast and beautiful. It is the feeling of being a single drop of water, aware for a moment of the entire, boundless ocean. It brings a sense of profound peace, a quiet awe that dissolves the small worries of our day. We are a tiny, thinking, feeling part of this grand, silent symphony of light and gravity. And for now, our little solar system continues its slow, patient journey through this luminous river of stars, a safe and quiet home in a cosmos of wonders. To drift through the great stellar nurseries of our galaxy is to witness the miracle of cosmic birth, to see new light kindled from ancient dust and gas. But our universe is a place of cycles, of perfect and unending balance. And so, for every star that is born, another, somewhere in the great luminous river, must reach the end of its long life. The story of a star's end, like its beginning, is written in the language of gravity and mass. For the vast majority of stars in our galaxy, including stars like our own Sun, the final chapters are a slow, graceful, and quiet letting go. After billions of years of steady, patient fusion, burning hydrogen into helium, the star's core will begin to run out of its primary fuel. It will swell dramatically, becoming a red giant, its outer layers expanding to engulf the orbits of its inner planets. Then, over a few thousand years, a mere moment in cosmic time, it will gently puff these outer layers away into space. This expanding shell of luminous gas, illuminated by the hot, tiny core left behind, creates one of the most beautiful objects in the cosmos. A planetary nebula. They are cosmic smoke rings, ethereal ghosts of departed stars, painted in the same soft hues of red hydrogen and blue-green oxygen that we see in stellar nurseries. At the heart of this delicate, fading shroud, the star's core remains as a white dwarf, a dense, Earth-sized ember of carbon and oxygen that has no fuel left to burn. It will simply cool and fade over trillions of years, a diamond in the cosmic darkness, a quiet memory of the light it once gave. This is the peaceful end that awaits most stars, a gentle sigh that returns their substance to the void. But for the giants of the galaxy, the stars born with 8 times or more the mass of our Sun, the end is not a gentle fading, but a final, glorious, and profoundly creative act. These massive stars live their lives in the cosmic fast lane. They burn through their fuel with astonishing ferocity, shining with a brilliant, blue-white light that makes them visible across vast galactic distances. Their immense mass creates such incredible pressures in their cores that they can fuse heavier and heavier elements, moving from hydrogen to helium, then to carbon, oxygen, neon, and all the way up the periodic table to iron. But iron is a finality. The fusion of iron does not release energy. It consumes it. And so, when a massive star builds up a core of iron, its engine suddenly and catastrophically switches off. In less than a second, the delicate balance between the outward push of fusion and the inward crush of gravity is broken. Gravity wins. The star's core collapses upon itself at a quarter of the speed of light, crushing the matter into an incredibly dense ball of neutrons. This collapsing core then rebounds in a titanic shockwave, a wave of energy so powerful that it blasts the star's outer layers into space in a cataclysmic explosion we call a supernova. For a few weeks, this single, dying star can outshine all the other 100 billion stars in its galaxy combined. It is the grandest farewell in the universe, a final, brilliant shout of light that announces not just an end, but a magnificent new beginning. For within that brilliant, fleeting light of a supernova, the very substance of our world is forged. The universe, in its earliest moments after the Big Bang, created only the lightest elements: hydrogen, helium, and a tiny trace of lithium. Every other natural element, every substance that makes our world solid and diverse and alive, was created later, in the hearts of stars. The process is called nucleosynthesis, the synthesis of new atomic nuclei. The carbon in the trees, the oxygen in the air we breathe, the silicon in the rocks beneath our feet. These were all fused in the cores of sun-like stars and gently released in their planetary nebulae. But the heavier, richer elements of our world, the elements essential for the complexity of life, have a more dramatic origin. The iron that courses through our veins, allowing our blood to carry oxygen, can only be created in the final, frantic moments before a massive star collapses. And all the elements heavier than iron, the copper in our wires, the silver and gold we hold as precious, the uranium that holds the secret of atomic power, can only be forged in the unimaginable temperatures and pressures of the supernova explosion itself. That titanic shockwave is a cosmic forge, smashing atomic nuclei together to create the full, rich palette of the periodic table. The supernova, then, is not an act of destruction. It is the ultimate act of cosmic creation and generosity. It is the universe seeding itself with the raw materials for complexity and for life. As we rest here tonight, feeling the gentle weight of our bodies, the slow and steady rhythm of our breath, we can reflect on this profound and beautiful truth. Every single atom in your body, apart from the primordial hydrogen, was born inside a star. The calcium that gives strength to your bones, the carbon that forms the backbone of your DNA, the iron in your blood, all of it was forged in the fiery heart of a star that lived and died billions of years ago, long before our Earth was ever formed. The elements that make you you were then cast out into the galaxy in a magnificent supernova explosion, scattered across light years of space. For millions of years, these atoms drifted as part of a great, enriched cloud of gas and dust, a cosmic nebula. And then, slowly, patiently, gravity pulled that very cloud together to form a new star, our Sun, and a family of new planets, including our Earth. The iron from that ancient star formed the core of our world, giving us our protective magnetic field. The carbon and oxygen and nitrogen became the building blocks of our oceans, our atmosphere, and eventually, of life itself. We are not just living in the universe lives in us. We are stardust. We are walking, talking, dreaming archives of cosmic history. And to know this is to feel a deep and unshakable sense of belonging, a connection to the grand, unfolding story of the cosmos that is written in our very bones. To know that we are made from the remnants of ancient stars is to feel an intimate connection to our own galaxy, the Milky Way. But now, let us allow our perspective to expand once more. Let us drift out of our luminous, starry home and into the vast, dark emptiness that separates the galaxies. From this new vantage point in the quiet of intergalactic space, we can look back and see the Milky Way in its entirety, a beautiful, swirling pinwheel of light. Our home, now just a single island in an archipelago of countless others. And as we float here, observing our galaxy, our gaze is drawn to another, nearby island of light. It is a stunning, majestic spiral, tilted at a graceful angle to our line of sight, appearing as a great, elongated oval of soft, ethereal light against the blackness. This is the Andromeda Galaxy, also known as Messier 31. It is our closest large galactic neighbour, a sister galaxy to our own, and yet it is separated from us by a gulf of 2.5 million light-years. The light we see from it tonight is a 2.5 million year old ghost. Andromeda is slightly larger than the Milky Way, containing perhaps 1 trillion stars to our few hundred billion. Seeing it from this peaceful distance, it feels like a cosmic reflection, a reminder that our home, as grand as it is not unique, but is part of a great cosmic family of such structures, each a self-contained universe of wonder. These two great galaxies, our Milky Way and Andromeda, are not static neighbours, observing each other from a respectful and permanent distance. They are, in fact, moving towards each other. We know this because of a subtle clue in Andromeda's light. When we look at distant, receding galaxies, their light is stretched out by the expansion of the universe, shifting it towards the red end of the spectrum in a phenomenon called redshift. But the light from Andromeda is different. It is blue-shifted. The waves of light coming from it are compressed, squeezed together, shifting them toward the blue end of the spectrum. This is the cosmic equivalent of the sound of a siren rising in pitch as it speeds towards you. It is the unmistakable sign that Andromeda is not moving away, but is rushing towards our Milky Way at a speed of over 100 kilometers per second. But there is no need for alarm. This is not a story of impending doom, but the beginning of a long, slow, and graceful dance. The force orchestrating this dance is the same one that holds our planets in orbit and our feet to the ground. Gravity. The immense, combined gravitational pull of these two giant galaxies is far stronger than the universe's expansion on a local scale, and so they are slowly, surely, and inevitably being drawn together into a cosmic embrace. The word collision sounds violent and destructive, but on a galactic scale, it is a far more gentle and creative process. When our two galaxies finally meet, in about 4.5 billion years, it will not be a crash of solid objects. The stars within galaxies are incredibly far apart relative to their size. If the Milky Way were the size of North America, The individual stars would be microscopic grains of dust, separated by kilometers. So, as the two galaxies begin to merge, as they pass through one another like two great ghosts of light, it is almost certain that not a single star will collide with another. Instead, the two galaxies will dance. Their powerful, interacting gravitational fields will warp and distort each other's beautiful spiral structures. Great, long streamers of stars and gas, called tidal tails, will be flung out into space, creating breathtaking arcs of light, hundreds of thousands of light years long. The vast clouds of gas and dust within each galaxy will be compressed and churned, triggering a spectacular burst of new star formation, a cosmic firestorm that will light up the merging galaxies with the brilliant blue light of billions of newborn stars. The two supermassive black holes at their centers will begin a long, slow, spiral, eventually merging into one, even larger black hole at the heart of the new, combined structure. This will not be a moment of destruction, but a period of profound and beautiful transformation. This grand, gravitational dance will continue for hundreds of millions of years. The two galaxies will pass through each other, swing back around, and merge again and again, their forms becoming more and more intertwined with each pass. Eventually, their separate identities will be lost, their spiral arms will dissolve, and their stars will settle into new, more randomized orbits. Out of the chaos of the merger, a new, single, and even grander galaxy will be born. Some astronomers have playfully nicknamed this future creation Milkomeda. It will not be a beautiful spiral like its two parents. Instead, it will likely be a giant elliptical galaxy, a vast, round or oval-shaped sphere of stars, glowing with the soft golden light of an older stellar population. The great burst of star formation will have used up most of the available gas, and the new galaxy will settle into a long, quiet, and peaceful old age. To contemplate this is to take the longest of views, to see time not on a human scale, but on a cosmic one. As we drift here in the quiet space between these two future partners, we can feel a deep sense of peace. We are witnessing the beginning of a love story written in gravity, a slow, inevitable dance of two giants, a silent promise of a shared future that will unfold in perfect, patient rhythm long after our sun has faded. To witness the slow, gravitational dance of our Milky Way and the Andromeda Galaxy is to understand that galaxies are not solitary islands, but are social, connected beings, bound to their neighbors by the invisible threads of gravity. This dance of two giants is just the central performance in a much larger and more intricate ballet. Our Milky Way and Andromeda are the two largest members of a small, gravitationally bound family of galaxies, known as the Local Group. This is our immediate cosmic neighborhood, a collection of more than 50 galaxies held together in a region of space, roughly 10 million light-years across. Besides the two great spirals, the rest of this family is composed of much smaller dwarf galaxies, faint and delicate collections of a few billion stars or less. Some of these, like the large and small Magellanic Clouds, are visible from the southern hemisphere as ethereal, cloud-like patches of light, loyal satellite galaxies orbiting our own Milky Way in a slow dance that has lasted for billions of years. Others are mere ghosts, faint wisps of stars so diffuse and dim that they are almost impossible to find against the backdrop of the sky. Our Local Group is a quiet, relatively peaceful galactic community, with its two great matriarchs slowly drawing all the smaller members inward as they themselves drift toward their inevitable merger. It is a comforting thought to know that our galaxy is not alone in the void, but is part of a local family, a gravitationally connected clan, drifting together through the great, dark ocean of intergalactic space. But as astronomers studied our galactic family and others like it, a profound and beautiful mystery began to emerge. When they carefully measured the speeds of stars orbiting within these galaxies, they found something deeply puzzling. Logic, and our own solar system, would suggest that the stars on the outer edges of a galaxy, being farther from the central mass, should orbit much more slowly than the stars closer to the core, just as distant Neptune plods along in its orbit compared to swift Mercury. But this is not what they found. The pioneering work of astronomers like Vera Rubin revealed, time and time again, that the stars in the outer reaches of spiral galaxies were moving just as fast. and in some cases even faster, than the stars near the center. It was a discovery that seemed to defy the known laws of gravity. A galaxy spinning this fast should, by all rights, fly itself apart, its outer stars flung off into the void like water from a spinning wheel. The fact that they do not, the fact that galaxies hold themselves together in such stable, beautiful forms, pointed to a startling conclusion. There must be a tremendous amount of extra mass within these galaxies, a mass that we cannot see, providing the extra gravitational glue needed to hold them together. The visible stars, the gas, the dust, all the things we could detect added up to only a fraction of the mass that had to be there. This mysterious, unseen substance was given a simple and evocative name: dark matter. It is called dark not because it is black or shadowy, but because it is utterly and completely invisible. It does not emit, absorb, reflect, or interact with light in any way. It is a form of matter that is transparent to the entire electromagnetic spectrum. An immense cloud of it could be passing through the room with you right now, and you would never know it. It does not seem to interact with the normal matter of our world, the atoms that make up our bodies, our planet, and the stars in any way at all, except for one. It has mass, and therefore it has gravity. Dark matter is the silent, unseen majority of the cosmos. All the luminous galaxies, all the beautiful nebulae, all the stars and planets and living things, all the things we think of as the universe, make up only about 5% of its total mass and energy. About 27% is this strange, invisible, dark matter. It is a ghostly, ethereal substance that forms the true underlying structure of our universe. We can imagine it as a vast, invisible scaffolding, a silent, transparent framework upon which the luminous, visible universe has been built. It is the hidden architecture of reality, the unseen hand that guides the dance of galaxies and holds them in its gentle, gravitational embrace. The prevailing theory today is that every galaxy, our own Milky Way included, is embedded within a vast, spherical halo of this dark matter. This halo is not just a small addition to the galaxy, it is the galaxy's dominant component. It is a colossal, invisible sphere, perhaps 10 times wider and far more massive than the luminous spiral disk of stars we can see. The beautiful, swirling river of stars that we call home is just the visible, shining portion at the very center of a much larger, darker, and more mysterious object. This immense halo of invisible mass is the solution to the puzzle of the spinning stars. It is its powerful, pervasive gravity that grips the outer stars and keeps them in their swift orbits, preventing the galaxy from tearing itself asunder. So, when we look up at the night sky, we are seeing only a fraction of the story. We see the bright, shining jewels, but we do not see the immense, invisible setting in which they are placed. To know this is to feel an even deeper sense of peace and security. Our galaxy is not a fragile, lonely structure. We are nestled at the heart of a vast, invisible, and protective sphere. A silent guardian whose gravitational embrace provides the stability and structure for our cosmic home to exist. The universe is far more grand, more mysterious, and more substantial than what meets the eye. To feel our galaxy nestled within its vast, invisible halo of dark matter gives us a sense of its true, grander nature. And just as our perspective expanded from a single star to a galaxy, it must now expand once more. For our local group, this cozy family of 50-odd galaxies is itself just one small part of a far larger congregation. As we drift further out, we begin to see that galaxy groups are themselves clustered together into even bigger structures. We are on the distant, quiet outskirts of a massive collection of galaxies known as the Virgo cluster. This is a true galactic metropolis, containing over 1,000 galaxies, all bound together by their mutual gravity, swarming around a common center like bees around a colossal unseen hive. And this great cluster, along with our own local group and about 100 other groups and clusters, is part of an even more magnificent structure, a supercluster. For a long time, we believed we were part of what we called the Virgo supercluster. This structure is a sprawling, flattened collection of thousands of galaxies, a celestial continent stretching for over 100 million light-years. To be a part of it is to realize that our local family is but one small town in a vast, interconnected nation of galaxies. But even this grand view has recently been transformed by a new and more profound understanding of our place in the cosmos. By mapping the motions of tens of thousands of galaxies, astronomers have been able to trace the great cosmic currents of gravity. They discovered that the Virgo supercluster itself is just one lobe of an even larger supercluster, a structure so immense that it challenges the imagination. They named it Laniakea, a beautiful Hawaiian name that means immeasurable heaven. Laniakea is not just a collection of galaxies in one region of space. It is defined by motion, by a shared gravitational destiny. It is a vast domain containing 100,000 galaxies, including our own, all flowing inward toward a single, common point in space called the Great Attractor. We can imagine Laniakea as a colossal watershed on a continental scale. Each galaxy is a drop of water, each group and cluster a stream or a river, and they are all flowing along the gentle, invisible contours of gravity, downhill toward the same great basin. Our Milky Way is moving through space at over 2 million kilometers per hour, a motion that is not random, but is part of this great, coherent, cosmic flow. To know that we are a part of Laniakea is to understand that our galaxy's journey is not a lonely one. We are part of a grand, collective pilgrimage, a silent, majestic river of galaxies flowing through the cosmos. As astronomers mapped these superclusters like Laniakea across the entire sky, an even more breathtaking picture of the universe's architecture was revealed. The galaxies, the clusters, the superclusters, they are not distributed randomly throughout space. They are arranged in a magnificent, intricate, and coherent pattern on the largest of scales. They form a vast, interconnected network that has come to be known as the cosmic web. Imagine a delicate, luminous tapestry stretching across the entire observable universe. This tapestry is made of immense, glowing threads called filaments, long, twisting braids of superclusters and galaxies that can stretch for hundreds of millions of light-years. At the places where these filaments intersect, we find the densest and most massive galaxy clusters, the great bustling nodes of the cosmic network. And in between these luminous threads are the great cosmic voids, vast, dark, and nearly empty bubbles of space, some so large that it would take light hundreds of millions of years to cross them. Our universe, on its grandest scale, is a beautiful, foam-like structure of interconnected filaments and deep, silent voids. We are not living in a random scattering of points, but within a single, unified, and breathtakingly intricate structure. This beautiful, web-like structure is the grandest prediction and confirmation of our theories about dark matter. When we run computer simulations of the evolution of the universe, starting with the faint ripples of density seen in the cosmic microwave background, we see this very same structure emerge. In the early universe, it was the invisible dark matter that, through its relentless gravitational pull, collapsed first into this immense, web-like scaffolding. Normal matter, the hydrogen and helium gas that we are made of, then followed suit, drawn by gravity into these great, dark filaments. Like dew forming on a spider's web at dawn, the normal matter collected along this invisible cosmic framework, cooled, and began to form the first stars and galaxies. And so, the luminous galaxies we see today are merely lighting up the densest parts of this pre-existing, invisible web. The entire visible universe is a delicate, shining embroidery stitched onto a vast, dark, and unseen tapestry. As we settle into a state of deep relaxation, we can hold this image in our minds. Our world, our sun, our galaxy, all part of a single, luminous thread in an infinite, interconnected web, a structure of profound beauty, order, and peace, holding everything in its cosmic embrace. To imagine the great cosmic web, this luminous tapestry of galaxies stretching across the universe, is to picture it with our human eyes, to see it as a grand structure of visible light. But the story that our eyes tell us, as beautiful and as vast as it is only a single chapter in a much larger and more mysterious book. The light that our eyes have evolved to see, the familiar rainbow of colors from red to violet, is but a tiny, sliver-thin window in a vast and continuous spectrum of light, an immense range of energies that permeate the entire cosmos. This is the electromagnetic spectrum. We can imagine it as a grand, cosmic piano keyboard, stretching infinitely in both directions. In the middle is the single, small octave of visible light that we can perceive. But to one side, the keys descend into lower and lower energies, producing the long, gentle waves of infrared, which we feel as heat, then microwaves, and finally the longest, lowest energy notes of all, radio waves. To the other side, the keys climb into higher and higher energies, moving past violet into the energetic realms of ultraviolet, then the powerful notes of X-rays, and finally, the highest energy, shortest wavelength vibrations of all, gamma rays. The universe is playing music on all of these keys, all the time. It is broadcasting stories in every form of light, whispering in radio waves, murmuring in infrared, shouting in gamma rays. To truly understand the cosmos, to see the cosmic web in all its intricate glory, we must learn to see with more than just our eyes. We must build new senses, new eyes, to perceive these invisible colours. And so, over the last century, we have done just that. We have built telescopes not of glass and mirrors alone, but of great metal dishes to catch the faint radio whispers of distant galaxies, and sensitive supercool detectors to feel the gentle warmth of infrared light. We have sent satellites into orbit, high above the blurring veil of our atmosphere, to capture the energetic X-rays and gamma rays that our airy blanket mercifully protects us from. This is the art of multi-wavelength astronomy, and it has revolutionized our view of the universe. Each new form of light, each new set of eyes, reveals a layer of reality that was previously hidden from us, a part of the story we never knew was being told. When we look at a seemingly quiet patch of sky in visible light, and then turn our radio eyes upon it, we might see vast, swirling jets of energy being ejected from a supermassive black hole. When we look at a cluster of galaxies with our X-ray eyes, we find them bathed in an immense, previously unseen cloud of superheated gas, a substance far more massive than all the stars in those galaxies combined. To see the universe in these different lights is to understand that it is a place of profound and layered complexity. It is to learn that what we perceive as empty space is often teeming with energy and structure, and what appears simple and serene is often the site of incredible, dynamic processes. It is a deeply humbling and awe-inspiring realization that the universe we see is only a pale shadow of the universe that truly is. Let us imagine, for a moment, that we are drifting towards one of those beautiful stellar nurseries we spoke of earlier, a place like the famous Pillars of Creation within the Eagle Nebula. In visible light, it is a breathtaking sculpture of dark, dense towers of dust and gas, silhouetted against the glow of a nearby star cluster. We see the cloud, but we cannot see what is happening deep inside it. The dust is like a thick fog, obscuring our view. But now, let us gently close our visible light eyes and open our infrared ones. Infrared light, with its longer wavelength, can pass through these dense clouds of dust, just as sunlight can pass through a thin curtain. And as we look again, the dark pillars become translucent, ghostly, and semi-transparent. And within them, a revelation. We see hundreds, even thousands, of tiny, glowing, reddish points of light that were completely invisible before. These are the newborn stars, the infant suns still swaddled in their dusty cocoons, their gentle, youthful warmth now visible to us as infrared light. To see the nebula in this way is a profoundly intimate experience. We are no longer outside looking in. We are peering directly into the cosmic womb, witnessing the very first moments of stellar birth. This is the gift of seeing with unseen light. It does not just show us new objects, it reveals the hidden processes of the universe, the gentle, creative forces that are forever at work in the quiet darkness. If infrared light reveals the gentle warmth of birth, then the high-energy light of X-rays and gamma rays reveals the universe at its most powerful and extreme. When we turn our X-ray telescopes to the sky, we see a universe that is not calm and gentle, but fierce and energetic. We see the glowing, shredded remnants of supernova explosions, vast, expanding clouds of gas heated to millions of degrees. We see matter being torn apart as it spirals into the intense gravitational field of a black hole, heating up and screaming in X-rays before it crosses the event horizon and vanishes forever. And with our gamma-ray eyes, the most powerful vision of all, we can witness the most violent events in the cosmos. The collision of two neutron stars, or hypernovae. Explosions of stars so powerful they make a normal supernova look like a firecracker. From our peaceful, drifting perspective, there is no fear in seeing the universe in this way. There is only a profound sense of awe. It is like listening to a great symphony and appreciating not just the soft, gentle melodies of the violins, but also the powerful, thundering crescendos of the drums and brass. The universe is a place of both gentle creation and immense power, of quiet cradles and magnificent fireworks. And all of these stories are being written in light, carried across the void for us to read, reminding us that the reality we perceive is just a single, beautiful note in a grand, cosmic song. As we learn to listen to the grand cosmic song played in every key of light, from the lowest notes of radio to the highest cries of gamma rays, a natural question begins to form in our quiet, drifting thoughts. What is the oldest note in this symphony? What is the most ancient light of all? The first sound to be uttered in the story of our universe? To find it, we must tune our senses to the realm of microwaves, that gentle, quiet frequency between infrared and radio. And when we do, when we build a telescope capable of hearing these faint, cool notes, we find something astonishing. We find that no matter where we look in the sky, in any direction, far from any star or galaxy, the universe is not completely dark or cold. All of space, every single point in the cosmos, is filled with a faint, perfect, and uniform glow of microwave radiation. It is a gentle, pervasive warmth, a light that is coming from everywhere and nowhere at once. This is the cosmic microwave background, the CMB, and it is nothing less than the afterglow of creation, the faint, residual heat from the Big Bang itself. It is the universe's first whisper, the oldest and most profound story ever told. The discovery of this ancient whisper was one of the most beautiful and serendipitous moments in the history of science. In 1965, at Bell Labs in New Jersey, two radio astronomers named Arno Penzias and Robert Wilson were using a large horn-shaped antenna to study faint radio signals from the Milky Way. But they were troubled by a persistent, low, steady hiss in their data, a noise that remained constant no matter where they pointed their antenna. They checked their equipment, they rewired their systems, they even climbed into the antenna and cleaned out what they delicately referred to as a white dielectric material, otherwise known as pigeon droppings, thinking it might be the cause of the interference. But the hiss remained. It was a perfectly uniform signal, coming from every direction of the sky, day and night, season after season. Unbeknownst to them, just a few miles away at Princeton University, a team of physicists was busy building a detector to search for the very thing that Penzias and Wilson were trying so desperately to eliminate. They were searching for the predicted thermal echo of the Big Bang. Eventually, the two groups were put in touch, and the realization dawned. The gentle, annoying hiss in the antenna was not noise. It was the signal. It was the sound of the infant universe, a message that had been traveling through space for 13.8 billion years, to finally end its journey in a humble antenna in New Jersey. It was a profound, accidental communion with the dawn of time. What makes this cosmic microwave background so remarkable is its near-perfect uniformity. The temperature of this ancient light is almost precisely the same across the entire sky, an incredibly stable 2.725 degrees above absolute zero. This uniformity tells us that the early universe was a place of incredible smoothness, a hot, dense, and almost perfectly even soup of matter and energy. But the true secret of our existence lies not in this smoothness, but in its almost imperceptible imperfections. When we map the CMB with incredibly sensitive satellites, we find that there are minuscule variations in its temperature, tiny fluctuations from one spot in the sky to another that amount to a difference of only 1 part in 100,000. There are patches that are ever so slightly warmer and patches that are ever so slightly cooler than the average. These are not random imperfections or noise in the data. They are real. They are the genuine texture of the infant universe, a fossilized record of the state of the cosmos when it was only 380,000 years old. These tiny, almost insignificant ripples in the temperature of the early universe are the most important features in the entire cosmos, for they are the seeds of everything that exists today. The slightly warmer, slightly denser patches in that primordial soup had just a little bit more matter, and therefore just a little bit more gravity than the cooler, less dense regions. And in the patient, unhurried expanse of cosmic time, that tiny initial advantage was everything. Over millions and then billions of years, these denser regions acted as gravitational seeds, their gentle pull relentlessly drawing in more and more matter, both the mysterious dark matter and the normal atomic matter. The rich got richer. The voids grew emptier. The material of the universe was slowly sculpted by this patient, persistent gravity, drawn into great, interconnected sheets and filaments. These filaments then collapsed in on themselves to form the first galaxies and galaxy clusters. Within those galaxies, gas clouds collapsed to form stars. Around those stars, dust gathered to form planets. And on at least one of those planets, life emerged. Every grand structure we see in the universe today, the great cosmic web, our own Milky Way, our Sun, our Earth, and even ourselves, is a direct descendant of one of those tiny, random fluctuations in the ancient light of the cosmic microwave background. And so, as we settle into sleep, we can feel ourselves bathed in this gentle, ancient warmth, a whisper from the dawn of time, carrying the story of the seed from which we grew. The cosmic microwave background is a perfect, fossilized image of our universe when it was a mere infant, just 380,000 years old. It is a beautiful, serene portrait of the cosmos, at the moment it first became transparent, the moment that light was finally set free to begin its long, uninterrupted journey through space. But this image, as ancient and as profound as it is, naturally guides our quiet thoughts to an even deeper and more fundamental question. What happened before this picture was taken? What was our universe like in its very first moments, in the time before light could travel freely? To answer this, we must drift back in our minds to the very beginning of the story, to the theory that forms the foundation of all modern cosmology. This is the Big Bang. The name itself is perhaps a little misleading, as it conjures images of a chaotic, fiery explosion, a bomb going off in the center of an empty space. But the reality is far more elegant, more profound, and more peaceful. The Big Bang was not an explosion in space. It was the beginning of the expansion of space itself. It was a moment, 13.8 billion years ago, when the entire observable universe, all space, all time, all matter, and all energy, was contained within a point of unimaginable density and heat, a singularity. And from that single, infinitesimal point, space itself began to unfurl, to stretch, to expand in all directions, carrying the nascent energy and matter of the cosmos along with it. A beautiful way to imagine this is to think of a loaf of raisin bread rising in an oven. The dough is space-time, and the raisins are the galaxies. As the dough expands, every raisin moves away from every other raisin. From the perspective of any single raisin, all the others appear to be rushing away from it. But there is no center to the expansion within the dough itself. The expansion is happening everywhere at once. So it was with our universe. It was a serene, silent, and perfect unfolding of space-time from a single, simple beginning. In the first few fractions of a second of this unfolding, the universe was an indescribably hot and dense plasma, a seething, energetic soup where matter and energy were indistinguishable and the fundamental forces of nature were unified into a single, perfect force. But as space expanded, it cooled, and as it cooled, the universe began to take shape, to crystallize into the forms we know today. The unified force separated into the distinct forces of gravity, the strong and weak nuclear forces, and electromagnetism. The primordial energy congealed into the first fundamental particles. For the first 3 minutes, the entire universe was a cosmic-scale nuclear furnace. Protons and neutrons, The building blocks of atomic nuclei were formed, and then they began to fuse together in a process called Big Bang nucleosynthesis. This was the universe's very first act of creation, forging the simplest and most abundant elements: vast quantities of hydrogen, a significant amount of helium, and a tiny, trace amount of lithium. For the next 380,000 years, the universe continued to expand and cool, but it remained a dense, opaque fog. It was so hot that electrons were unable to settle down with the atomic nuclei, instead flying free in a hot, ionized plasma. The photons of light that filled this plasma could not travel far before crashing into one of these free electrons, being scattered and absorbed. The universe was a glowing, impenetrable mist, with no way for light to shine through it. The beautiful picture of the cosmic microwave background is the very moment this fog finally cleared, the moment the universe cooled enough for electrons to be captured by the nuclei, forming the first stable, neutral atoms. At that instant, the light was set free, and the universe became transparent for the very first time. This story of a smooth, hot, expanding universe beautifully explains almost everything we see, but it leaves a few gentle, persistent puzzles. For one, the cosmic microwave background is almost too perfect, too uniform in its temperature across the entire sky. How could regions of the universe that were once so far apart that light never had time to travel between them have settled into the exact same temperature? To explain this and other subtle features of our cosmos, cosmologists have imagined a prequel to the Big Bang story, a moment before the moment, called cosmic inflation. According to this idea, in the very first fraction of a second after the beginning, a sliver of time so small it is almost incomprehensible, the universe underwent a period of astonishing, hyper-accelerated expansion. Space itself expanded faster than the speed of light, taking a region of the universe smaller than a proton and stretching it to a size larger than a galaxy, all in an instant. It is a mind-bending concept, but it provides a beautifully elegant solution to the puzzles. This period of inflation would have taken any initial wrinkles or irregularities in the fabric of space-time and stretched them out completely flat, just as blowing up a crumpled balloon makes its surface appear smooth and uniform. This would explain the incredible smoothness we see in the cosmic microwave background. All the regions we see in the sky today were once intimately connected, in thermal equilibrium, before inflation ripped them apart and flung them to opposite ends of the cosmos. Cosmic inflation also provides a beautiful origin story for the seeds of cosmic structure. The theory suggests that during this period of incredible expansion, tiny, random quantum fluctuations, little jitters in the energy of empty space, were stretched to enormous astrophysical scales. These microscopic quantum ripples became the macroscopic seeds of density, the tiny hot and cold spots that we now see imprinted on the cosmic microwave background. These are the very seeds that would later grow into all the galaxies and all the structure in the universe. And so, our story of the beginning becomes even more profound. It begins with a single point, which then undergoes a moment of breathtakingly rapid expansion, smoothing itself out and planting the seeds for the future. This gives way to a more gentle, continued expansion, where the universe cools, and the first and simplest elements are forged in a cosmic wildfire. Then comes a long period of cooling in a dense, glowing fog, until finally the universe becomes transparent, releasing the ancient light that we can still see today. This is our creation story, written in the language of physics. It is a story of a serene, perfect unfolding, a gentle yet powerful expansion from the simplest of beginnings into the magnificent, structured cosmos we inhabit, a cosmos built from the hydrogen and helium forged in its very first minutes. The story of our universe's beginning is one of a powerful, outward unfolding, an expansion that began 13.8 billion years ago and continues to this very day. For much of the 20th century, cosmologists pondered the ultimate fate of this expansion. The universe is filled with matter galaxies, stars, gas, and the immense, unseen halos of dark matter, and all of this matter has gravity. Gravity is a force of attraction, a cosmic brake that should be constantly pulling inward, working against the initial outward momentum of the Big Bang. The great question was, which force would win? Would the universe have enough matter, enough gravitational pull, to eventually halt its expansion and fall back in on itself in a big crunch? Or would the expansion continue forever, slowing down over time but never quite stopping? For decades, astronomers sought to measure this cosmic deceleration to determine just how much the universe was slowing down. And so, in the late 1990s, two separate teams of scientists set out to do just that, using a special kind of exploding star, a Type 1a supernova, as a clever measuring tool. These supernovae act as standard candles, meaning they all have a known, predictable brightness, allowing astronomers to calculate their distance with great precision. By comparing their distance with their redshift, the teams could map the history of cosmic expansion. They expected to find the gentle, steady, slowing down that everyone predicted. But they found something that no one, in their wildest dreams, had expected. The expansion of the universe is not slowing down. It is speeding up. It is accelerating. This discovery was so profound, so utterly contrary to all expectation, that it changed our understanding of the universe overnight. It meant that there must be a mysterious, unseen force at work in the cosmos, a force that is not pulling things together, but is actively pushing them apart. This enigmatic force was given a name as mysterious as its nature: dark energy. It is important to remember that dark energy is a completely separate mystery from dark matter. Dark matter is a form of substance, a particle we have not yet discovered, that has gravity and clumps together, forming the invisible halos that hold galaxies together. Dark energy is something else entirely. It does not seem to be a substance at all. Instead, it appears to be an intrinsic, fundamental property of the fabric of space itself. Every cubic centimeter of empty space, every quiet corner of the deepest void, seems to be filled with a tiny, persistent, and repulsive energy. It is a kind of anti-gravity, a gentle, constant pressure that is causing space-time itself to stretch and expand at an ever-increasing rate. And this energy is not a minor component of the cosmos. According to our best measurements, all the normal matter we can see, plus all the invisible dark matter, makes up only about 32% of the total mass energy content of the universe. The other 68%, the overwhelming majority, is this strange, ghostly, and powerful dark energy. What is perhaps most beautiful about this astonishing discovery is that it echoed an idea that the great physicist Albert Einstein had more than 80 years earlier. When Einstein first formulated his theory of general relativity, his equations suggested that the universe should be either expanding or contracting. But the prevailing view at the time was that the universe was static and eternal. So, to make his equations fit with this idea, he added a mathematical fudge factor, a term he called the cosmological constant, which represented a repulsive energy inherent in the vacuum of space that would perfectly counteract gravity and hold the universe in a static balance. A few years later, when observations showed that the universe was in fact expanding, Einstein discarded the idea, famously calling it his biggest blunder. But in a moment of beautiful cosmic irony, it now seems that his blunder may have been his most prescient prediction. The dark energy that is causing the universe's expansion to accelerate behaves exactly like Einstein's cosmological constant. His fudge factor, invented for the wrong reason, may be a perfect description of the real, mysterious energy that dominates our cosmos. The universe is not static, but the energy that Einstein imagined may be the very force that is shaping its ultimate destiny. This accelerating expansion, driven by dark energy, paints a serene, if somewhat lonely picture of the universe's far future. As space expands ever faster, the distant galaxies we see today will be pushed away from us at an accelerating rate. Eventually, they will recede from us so fast that their light will no longer be able to reach us, even traveling at the ultimate cosmic speed limit. One by one, they will cross a cosmic horizon and vanish from our view, their light redshifted into oblivion. In 100 billion years, the night sky for any observer in our galaxy will be a very different place. All the distant galaxies and clusters will have disappeared, leaving only the stars of our own Milky Way and the few galaxies like Andromeda that are gravitationally bound to us in our local group. The grand, luminous tapestry of the cosmic web will have been stretched so far that it will be entirely invisible to us. The universe will settle into a state of increasing isolation and quiet. This long, slow fate is sometimes called the Big Freeze or the heat death, but perhaps a more peaceful way to imagine it is as a long, slow, cosmic exhale. The universe is not dying a violent death. It is simply breathing out. It is stretching, cooling, and settling into a state of ultimate tranquility and peace, a final, serene state of deep and lasting quiet, as the last stars eventually flicker and fade into the growing, gentle darkness. To contemplate the far future of our universe, to see the galaxies gently receding from one another in a long, slow exhale, is to feel a sense of immense and profound solitude. The cosmic stage is so vast, and the distance is so great, that it is easy to feel that we are alone. And yet, even as the space between the galaxies expands, the galaxies themselves remain as vibrant and rich as ever. Great, swirling islands of light and potential. And so, our journey now turns away from the grand, intergalactic voids and pulls its focus back into our own Milky Way, into the quiet neighborhoods around the countless other suns that share our galactic home. For centuries, for millennia, the stars were simply points of light. We wondered if they, like our own sun, were attended by families of planets, but it was a question that belonged to philosophy and dreams, not to science. But in the last few decades, that has all changed. Those distant points of light have begun to resolve into places, into potential destinations. We have entered the age of exoplanets, the age of discovering worlds beyond our own solar system, and we have found them not in the dozens or the hundreds, but in the thousands. The night sky has been transformed. It is no longer a collection of lonely stars, but a vast archipelago of possible solar systems. The methods we use to find these distant worlds are acts of incredible patience and precision. The most successful of these is the transit method. It is a technique of profound simplicity and elegance. A space telescope will stare, unblinking, at a patch of sky containing tens of thousands of stars, measuring their brightness with exquisite accuracy over and over again, and it will watch and wait for a telltale sign. A tiny, subtle, and perfectly regular dimming of a single star's light. This minuscule dip in brightness, often just 1 part in 10,000, is the signature of a planet passing in front of its star from our perspective. A tiny, partial eclipse. It is like watching a distant lighthouse from across a vast ocean and noticing the faintest, rhythmic dimming as a tiny, unseen moth flits across its beam. From that subtle dimming, we can learn so much. By how much the light dims, we can determine the size of the planet. By the timing of the transits, how long it takes the planet to orbit its star, we can determine its year and its distance from its sun. It is a beautifully quiet and meditative form of discovery, a patient vigil that has revealed a universe far richer in worlds than we had ever dared to imagine. As we began to discover this treasure trove of new worlds, the first question that naturally arose was a hopeful one. Could any of them harbour life? To begin to answer this, we needed a way to narrow down the search, a place to start looking. And so, the concept of the habitable zone was born. It is more affectionately known as the Goldilocks zone, and the name captures its essence perfectly. For any given star, there is a region of space around it where the conditions are not too hot and not too cold, but just right for liquid water to potentially exist on the surface of a rocky planet. If a planet orbits too close to its star, the intense radiation would boil any water away into space. If it orbits too far, any water would be locked away as solid ice. But in that temperate, in-between region, that gentle, life-friendly band of orbits, the energy from the star is just enough to allow for the possibility of liquid oceans, rivers, and lakes. And liquid water, as far as we know, is the essential solvent for the complex chemistry that gives rise to life. The habitable zone, then, is a zone of pure possibility. Finding a planet, there is no guarantee of life, but it tells us that a world has received the first and perhaps most crucial of invitations to the great dance of biology. To find out if any of these worlds has accepted that invitation, we must find a way to listen for the whispers of life across light years of empty space. and we are learning to do so by analyzing the very air of these distant worlds. When a planet with an atmosphere transits its star, a tiny fraction of the starlight passes through that atmosphere on its way to our telescopes. And as it does, the gases in that atmosphere absorb certain specific colors or wavelengths of the starlight, leaving a unique chemical fingerprint on the light that reaches us. By carefully studying this fingerprint, we can begin to deduce what that distant world's air is made of. We can look for the telltale signs of water vapor, of carbon dioxide, of methane, and perhaps, one day, we will find the unmistakable signature of abundant oxygen. On our Earth, oxygen is overwhelmingly a product of life, of photosynthesis. To find it in the atmosphere of a distant exoplanet would be a profound and perhaps definitive biosignature, a sign that the silent chemistry of a world has been transformed by a living biosphere. This patient, beautiful work of deciphering the breath of other worlds leads us to contemplate the grand, organizing question posed by the astronomer Frank Drake. His famous Drake equation is a string of probabilities: the rate of star formation, the fraction of stars with planets, the number of those planets that are habitable, the fraction on which life arises, and so on. It is not meant to give us a firm answer. It is meant to be a poem to our own hopeful ignorance, a structured meditation on the chances, a quiet acknowledgement that the universe is now filled not with stars, but with islands of endless and beautiful possibility. Our search for life in the cosmos often begins as a search for ourselves. We look for planets like Earth, orbiting stars like our Sun, in a gentle habitable zone where liquid water might grace the shores of alien continents. This is a natural and hopeful place to start, but the story of life on our own planet suggests that perhaps this view is a little too narrow, a little too constrained by our own familiar experience. What if life is not a delicate flower that can only bloom in the most pristine and perfect of gardens? What if, instead, life is a tenacious, wild, and incredibly imaginative force, capable of taking root and flourishing in the most unlikely and astonishing of places? To explore this idea, our journey must turn back from the distant stars and travel deep into the hidden corners of our own world, to meet the creatures that thrive in environments we once thought were utterly uninhabitable. These are the extremophiles, the lovers of extreme conditions, and they are the living embodiment of life's incredible resilience. They are a testament to the fact that where there is even the faintest glimmer of opportunity, life will find a way. Let us drift down into the deepest, darkest trenches of our oceans, kilometers below the surface, where the pressure is immense enough to crush steel, and where no ray of sunlight has ever reached. Here, we might expect to find nothing but a cold, sterile desert. But instead, we find bustling, vibrant oases of life, clustered around hydrothermal vents. These are great, rocky chimneys on the seafloor, spewing out superheated, mineral-rich water from deep within the Earth's crust. And clinging to these vents, in water hot enough to melt lead, are strange and beautiful communities of giant tube worms with blood-red plumes, ghostly white crabs, and dense mats of bacteria. On the surface of our world, we find other wonders. We find microbes that live in the boiling, acidic waters of volcanic hot springs, others that thrive in the hypersaline waters of evaporation ponds, and still others that have been found deep within the ice of Antarctica, frozen solid for thousands of years, yet still capable of being revived. There is even a bacterium, Deinococcus radiodurans, that can withstand doses of radiation 1,000 times greater than what would be lethal to a human, happily repairing its own shattered DNA and carrying on as if nothing had happened. These extremophiles are not freaks of nature. They are a fundamental part of our world's biosphere, and they teach us a profound and humbling lesson. Our definition of habitable is merely a reflection of our own biological limits. The discovery of the ecosystems around deep-sea hydrothermal vents was more than just another example of extremophiles. It fundamentally changed our understanding of the basic requirements for life. For all of human history, we believe that all life on Earth ultimately derived its energy from the sun. Plants and algae use photosynthesis to turn sunlight into chemical energy, and then animals eat the plants, or eat other animals that eat the plants. The sun was the great engine of all biology. But the creatures of the deep-sea vents live in eternal darkness. Their ecosystem is not powered by photosynthesis, but by a process called chemosynthesis. The bacteria that form the base of this food web are not using sunlight. They are harnessing the chemical energy contained in the compounds spewing from the vents, such as hydrogen sulfide. They are, in essence, eating volcanic chemicals. This was a revelation. It meant that life does not necessarily need a sun. It can arise and thrive in complete darkness, powered by the geological and chemical energy from a planet's own heart. Life can be a product of a world's own internal warmth and activity, completely independent of the star it orbits. This profound realization opens up entirely new and exciting possibilities for life elsewhere in our very own solar system. We can turn our gaze to Jupiter's moon, Europa. Its surface is a vast frozen shell of water ice, cracked and scarred, with a temperature of -160 degrees Celsius. By all our old measures, it is a barren, uninhabitable world. But we now know that beneath that thick ice shell lies a vast, global ocean of liquid saltwater, an ocean that may contain more water than all of the oceans of Earth combined. This ocean is kept liquid, not by the sun, but by the tidal forces of Jupiter, which flex and stretch the moon, warming its interior. It is entirely possible that at the bottom of this dark, alien ocean, there are hydrothermal vents, just like on Earth. And if there are vents, and water, and the right chemical ingredients, there could very well be life, a whole ecosystem of chemosynthetic organisms, living and dying in the dark, with no knowledge of the sunlit universe above their icy ceiling. Or we can journey to Saturn's great moon, Titan, a world shrouded in a thick orange haze. There, it is so cold that water is as hard as rock, and the rivers and lakes are filled not with water, but with liquid methane and ethane. Could a completely different form of life exist there? A biology based on methane instead of water, with cells that breathe hydrogen instead of oxygen? We do not know. But the sheer tenacity of life on Earth encourages us to keep our minds open, to understand that the search for life is not just a search for another Earth, but a search for the outer limits of biology's boundless imagination. Our journey together has carried us from the familiar shores of our own world, past the planets and the stars, through the heart of our galaxy, and out into the great cosmic web that connects all things. We have explored the tenacious nature of life, opening our minds to the possibility that it might bloom in the most unexpected of places. And now, as we drift in this quiet state of contemplation, our journey takes one final step outward, a step not into a place that we can see, but into the vast, beautiful, and unseen landscape of we travel to the very edge of physics, to the beautiful dreams and imaginative ideas that scientists use to try and understand the deepest nature of reality itself. For much of the last century, physics has rested on two colossal pillars: Einstein's general relativity, the theory of the very large, which describes gravity, space-time, and the dance of galaxies with perfect elegance, and quantum mechanics, the theory of the very small, which describes the strange, probabilistic world of particles and forces with stunning accuracy. Both theories work perfectly in their own realms, but at the extremes, in the heart of a black hole, or in the first moment of the Big Bang, the two theories collide, and the mathematics breaks down. For decades, the greatest minds in physics have dreamt of a single, unifying theory, a theory of everything that could weave these two pillars into a single, beautiful, and coherent structure. And the most promising and most mind-bending of these dreams is called string theory. The central idea of string theory is one of profound and simple beauty. It suggests that if we could zoom in on the fundamental particles of our universe, the electrons, the quarks, the photons, we would find that they are not, in fact, zero-dimensional points. Instead, we would find that at their most basic level, they are all tiny, one-dimensional, vibrating loops of energy, like infinitesimally small violin strings. And just as a single violin string can be played at different frequencies to produce a rich variety of different musical notes, these fundamental strings vibrate in different patterns, in different resonant frequencies. And each unique mode of vibration, each different note, presents itself to us as a different kind of particle. The vibration that we perceive as an electron is one note. The vibration that appears as a photon is another. The one that corresponds to a graviton, the particle of gravity, is yet another. In this view, the entire rich diversity of the universe, all the different particles and all the forces that govern their interactions, is nothing more than the different notes in a grand, cosmic symphony being played on these tiny, fundamental strings. It is an idea of breathtaking elegance, a vision of a universe built not from hard, billiard ball-like particles, but from pure, resonant, and harmonious vibration. For this beautiful mathematical music to play correctly, however, string theory requires something astonishing of our universe. It requires that our reality has more dimensions than the ones we can see. We experience our world in 3 dimensions of space, length, width, and height, and 1 dimension of time. But for the equations of string theory to be consistent, the universe must have 10 or even 11 dimensions. So where are these extra, hidden dimensions? The theory suggests that they are all around us, at every single point in space, but that they are curled up or compactified to a size so unimaginably small that we can never perceive them directly. A simple way to visualize this is to imagine a long, thin garden hose stretching across a field. From a great distance, the hose appears to be a simple, one-dimensional line. But as you walk closer, you realize it has a second dimension, the circular dimension of its circumference. In a similar way, our universe might have tiny, curled-up dimensions at every point in space. Dimensions that are so small they are imperceptible to us, but which provide the stage upon which the symphony of the strings is played out. This idea of tiny, hidden dimensions leads to the most spectacular and humbling vision of all. The mathematics of string theory does not produce just one unique solution. It suggests a vast, almost infinite landscape of possibilities, with a staggering number of different ways that these extra dimensions could be curled up and configured. Each of these different configurations would result in a universe with its own unique set of string vibrations, and therefore its own unique set of physical laws and fundamental constants. Our universe, with its specific laws of gravity and its particular family of particles, would be just one possible outcome among countless others. This gives rise to the multiverse hypothesis, the idea that our universe is just one bubble in a vast, cosmic foam of other, parallel universes, each existing with its own different laws of physics. If this is true, it offers a gentle, philosophical answer to one of the deepest mysteries. Why does our universe seem so perfectly fine-tuned for the existence of life? The anthropic principle suggests that if there are countless universes, it is no surprise that we find ourselves living in one of the very few that has the right conditions to create us. We exist in a life-friendly universe for the same reason we exist on a life-friendly planet. We are simply living in a place where we can live. And so, our journey to the furthest edges of physics leaves us with a sense of profound and peaceful wonder. The thought that our entire cosmos might be just one beautiful note in an infinite and unending song. To imagine a multiverse, the great cosmic foam of countless other realities, is to take our thoughts to the very edge of the conceivable, to the furthest possible shore of the great cosmic ocean out there. And now, having journeyed so far, our story begins its gentle return. But it is a return to a place that is, in its own way, just as vast, as mysterious, and as filled with wonder as the cosmos we have been exploring. For there is another universe, one that we carry with us every moment of our lives, a universe of thought and feeling, of memory and imagination. We now turn our journey inward, to the intricate, living cosmos of the human brain. And as we do, we find the most astonishing of echoes. In recent years, scientists have placed a computer simulation of the large-scale structure of the universe, the cosmic web, alongside a magnified image of a slice of the human brain's neural network. And the resemblance is breathtaking. The cosmic web, with its long, interconnected filaments of galaxies, its dense nodes where the clusters reside, and the great, empty voids in between, looks uncannily similar to the intricate web of neurons in our brain, with their long, branching axons connecting to cell bodies, forming a vast, electrochemical network. This is not to say that the universe is a giant brain, or that the brain is a tiny universe, but the striking similarity in their structure points to a deep and beautiful truth. The same laws of physics that govern the formation of the largest structures in the cosmos also give rise to the most complex structure we have ever discovered within it. The universe held within our skulls is a place of almost unimaginable complexity. The average adult brain contains roughly 86 billion neurons. Let us pause on that number for a moment. 86 billion. That is a number comparable to the number of stars in our Milky Way galaxy. Each of these neurons, these fundamental cells of thought, is a sophisticated, living processing unit. And they are not isolated. Each neuron forms connections, called synapses, with thousands of other neurons, weaving themselves into a network of such staggering density that there are more connections in a single human brain than there are stars in our home galaxy. The total number is estimated to be in the hundreds of trillions. It is through this vast, silent, and intricate dance of electrochemical signals, a storm of quiet lightning flashing between these trillions of connections, that everything we are and everything we experience comes to be. Every memory of a loved one's face, every note of a beautiful piece of music, every feeling of joy or sorrow, and indeed, the very act of comprehending the words you are hearing now is an emergent pattern of activity in this impossibly complex, living web. The 3 pounds of soft tissue resting within your head is the most complex object we have yet found in the entire known universe. How can this be? How can simple cells, made of the same stardust as the rest of the cosmos, give rise to the immaterial, ineffable experience of consciousness? The answer lies in one of the most beautiful concepts in all of science: emergence. Emergence is the idea that complex systems can exhibit properties that their individual components do not have. A single molecule of H2O is not wet, but put trillions of them together and the property of wetness emerges. A single bird has no sense of the beautiful flowing patterns of a flock, but when thousands of them fly together, following a few simple rules, the intricate and graceful ballet of the murmuration emerges. So it is with consciousness. A single neuron is not conscious. It has no thoughts, no feelings, no awareness. But when 86 billion of them are connected in just the right way, the miracle of self-awareness emerges. Our thoughts are not located in a single neuron. They are a holistic, emergent property of the entire system working in harmony. The brain, then, is a testament to the universe's incredible capacity to generate complexity, to build structures that can, in time, become aware of their own existence. This inner cosmos of the brain is not a static, fixed object. It is a dynamic, fluid, and ever-changing universe. Throughout our lives, our brains are constantly rewiring themselves in response to our experiences, a property known as neuroplasticity. Every time we learn a new skill, form a new memory, or have a new thought, we are subtly altering the physical structure of our brain, strengthening some connections and weakening others. The pathways of our inner universe are constantly being reshaped. This living, evolving network mirrors the dynamic cosmos we have explored, a universe where stars are born and die, where galaxies merge and are reshaped by gravity. The universe within us is just as alive, just as dynamic as the universe without. And as we settle into the deepest states of rest, we can reflect on this most profound of ideas. The stardust, forged in the hearts of ancient, dying stars, has, on this small blue planet, organized itself over billions of years into these complex, emergent structures. We are the universe's way of knowing itself. The matter of the cosmos has woken up, and through us, it looks back out at the vast and silent beauty from which it came, filled with a sense of peace and wonder and of coming home. To feel the universe of the mind, contemplating the universe of the stars, is to become aware of the very medium in which this contemplation takes place. The quiet, steady, and seemingly unwavering flow of time. In our everyday experience, time feels like a great, universal clock, ticking at the same constant rate for everyone, everywhere. It is a rigid, unbending ruler against which we measure our lives, a current that carries us inexorably from the past, through the present, and into the future. But the journey we have taken through the cosmos has taught us that our everyday intuition can often be a gentle illusion, a simplified view of a much deeper and more wondrous reality. And so it is with time. For the great mind of Albert Einstein revealed to us that time is not a rigid ruler, but a soft and flexible river. He showed us that space and time are not separate entities, but are two aspects of a single, unified reality. They are woven together into a dynamic, four-dimensional fabric called space-time. And this fabric is not just a passive backdrop for the events of the universe. It is an active participant. Massive objects like stars and galaxies do not simply exist in space-time. Their very presence causes this fabric to curve, to warp, to dimple, just as a heavy ball placed on a stretched rubber sheet creates a deep well around it. This is the essence of gravity. It is not a mysterious force that pulls, but the very shape of space-time itself, a landscape of valleys and hills that guides the motion of all things. And in this curved, flexible space-time, the flow of time itself becomes relative. The deeper you are within one of these gravitational wells, the more space-time is curved, and the slower the river of time flows. This effect is called gravitational time dilation. It is not a theoretical quirk, it is a real, measurable property of our universe. The clock on a satellite in high orbit, where gravity is slightly weaker, literally ticks a few microseconds faster every day than a clock down here on the surface of the Earth. The global positioning system that we use every day must constantly correct for this tiny difference in the flow of time to remain accurate. This effect, though minuscule in our daily lives, becomes profound in the extreme environments of the cosmos. If you could hover in a spaceship near the edge of a black hole, where space-time is curved to an incredible degree, your time would slow to a crawl compared to a distant observer. You might experience only a few hours, while for the rest of the universe, centuries or even millennia would pass. The river of time can be stretched and compressed by the presence of mass and energy. And it is not just gravity that alters its flow, motion does too. The faster you travel through space, the slower you travel through time. Time, then, is not absolute. Its pace is a personal, local experience, shifting and changing with gravity and speed, a flexible and fluid dimension of reality. We do not need to journey to a black hole to witness the effects of this warped space-time. We can see it with our own eyes, in the beautiful and dreamlike phenomenon known as gravitational lensing. Just as a glass lens can bend the path of light, so too can the curved space-time around a massive object. When light from a very distant galaxy travels towards us, and its path takes it close to another massive galaxy or a great cluster of galaxies, the light will follow the curve in space-time, its path bent as if by an invisible lens. This can create the most stunning and surreal images in our telescopes. We might see a single, distant quasar appear as four separate images arranged in a perfect cross, a configuration known as an Einstein cross, as its light is bent around an intervening galaxy. Or we might see the images of distant, blue, spiral galaxies stretched and distorted into long, graceful, and luminous arcs, their familiar shapes warped into ghostly rings of light around the massive foreground cluster. These images are more than just beautiful cosmic curiosities. They are direct, visual proof of the curvature of space-time. We are literally seeing the shape of the universe's gravitational landscape. We are watching light itself follow the gentle flowing contours of a reality that is far more strange and far more beautiful than our everyday senses can perceive. This physical reality of a flexible, relative time finds a beautiful and profound echo in the inner universe of our own minds. For we all know, from our deepest experiences, that psychological time is just as fluid as cosmological time. Our perception of time's passage is not constant. It stretches and compresses based on our emotional state, on our focus, on our engagement with the world. A few moments of intense joy or fear can feel like an eternity, while hours spent absorbed in a creative passion can vanish in what feels like an instant. Time seems to fly when we are happy, and it slows to a thick, syrupy crawl when we are sad, or bored, or in pain. And our minds have their own form of time travel. Through the power of memory, we can journey back into our own past, reliving experiences, rehearing conversations, re-feeling old emotions. The past is not gone. It is a vast inner landscape that we can visit at will. And through our capacity to hope, to dream, and to plan, we can project our consciousness into the future, imagining possibilities and shaping the path we wish to take. Our minds are constantly weaving the past, present, and future together into the rich tapestry of a single, coherent life. And so, as we allow our own sense of time to soften and expand in this quiet moment before sleep, we can find peace in this beautiful harmony between the inner and outer worlds, the knowledge that time is not a rigid cage, but a gentle, flowing, and ever-changing river. To feel time as a gentle, flowing river is to find a deep and abiding peace with its passage. But it also brings to mind a simple and profound question. Why does this river only flow in one direction? Why do we remember the past, but not the future? Why do we move inexorably from yesterday to tomorrow, and never the other way around? The fundamental laws of physics, for the most part, do not seem to care about the direction of time. They would work just as well forwards as they would backwards. Yet our experience of the universe is one of a clear and undeniable arrow of time. A glass that falls and shatters on the floor does not spontaneously reassemble itself and leap back into our hand. A drop of ink placed in a glass of water slowly diffuses, clouding the water until it is evenly mixed. It does not gather itself back into a perfect, tiny sphere. These processes are irreversible, and it is this irreversibility that gives time its direction. The answer to this deep mystery is found not in the laws of motion or gravity, but in one of the most fundamental and poetic laws in all of science, the second law of thermodynamics. This is the law of entropy. Entropy is often described as a measure of disorder, but a more gentle and intuitive way to understand it is as a measure of probability. The second law of thermodynamics simply states that any isolated system will tend to evolve from a less probable state to a more probable state. An ordered, separated state like all the ink molecules in one tiny drop, and all the water molecules separate is a very specific, low probability arrangement. A disordered, mixed state with the ink and water molecules randomly distributed is a far more generic, far more probable arrangement. There are simply vastly more ways for the molecules to be mixed up than for them to be perfectly separated. And so, the universe, in its constant, gentle, and random motion, tends to find its way towards these more probable states. This is the essence of entropy. It is the tendency for energy to spread out and disperse, for concentration to become dilution, for order to gently dissolve into uniformity. It is the story of a warm cup of tea, slowly cooling as its heat spreads into the surrounding room. It is the story of a puff of smoke dissipating on the wind. It is the quiet, inexorable, and peaceful unfolding of everything. This constant, gentle increase of entropy is what creates the arrow of time that we experience. The reason we remember the past is because the past was a state of lower entropy. Our minds themselves are entropy-creating machines. The very act of forming a memory, of imposing order on our neural pathways, requires energy and generates waste heat, increasing the total entropy of the universe. We move towards the future because the future is the direction of higher entropy, the direction of greater probability. The universe began in a very special, highly ordered, and incredibly low entropy state at the Big Bang, and the entire 13.8 billion year story of the cosmos has been the story of that initial state of low entropy, slowly and gracefully unfolding, like a perfectly wound clock, slowly unwinding. The formation of galaxies and stars might seem like an increase in order, but these are just temporary, local eddies in a great cosmic river that is flowing, overall, towards a state of greater dispersal and greater entropy. The irreversible processes of life and decay, of building and breaking, of mixing and fading, these are the very things that paint the arrow of time onto the canvas of reality. This deep connection between time, probability, and the spreading of energy brings a new, and perhaps more peaceful, understanding of the ultimate fate of our universe. We have spoken of the Big Freeze or the heat death as a consequence of dark energy and the accelerating expansion of space, but we can now see it through the lens of entropy. That far future state, where all the stars have burned out, all the black holes have evaporated, and all of matter has decayed into a thin, cold soup of fundamental particles in a vast and empty space, is simply the state of maximum entropy. It is the logical conclusion of the second law of thermodynamics. It is the state where all the energy of the cosmos has spread out as thinly and as uniformly as possible. It is the most probable state of all, the great equilibrium that the universe has been patiently and peacefully unfolding towards since its very beginning. It is not a tragic end, but a state of perfect and final tranquility. It is the universe finally coming to rest, its long and beautiful story told, its cosmic clock fully unwound. It is the universe's final, long, slow sigh, a perfect state of silence and stillness. And as we now prepare for our own nightly journey into rest, we can see the act of falling asleep as our own personal expression of this universal law. We release the ordered, energetic thoughts of the day. Our minds quiet down. Our bodies cool. We let go of the structure of our waking consciousness and drift, peacefully, towards the gentle, restorative, and high-entropy state of sleep. To feel the great law of entropy in the gentle letting go of our own waking consciousness is to bring our grand cosmic journey back to the most intimate of scales. We have travelled from the stardust in our bones to the shimmering edge of theoretical physics, from the dawn of time to its far, quiet future. And now, the river of our thoughts turns and begins its final, gentle journey home. Let us use the vast perspective we have gained to look back at our point of origin, to see our world as it truly is, from the cold, clear, and silent vantage point of deep space. In 1990, as the Voyager 1 spacecraft was speeding towards the edge of our solar system, having completed its grand tour of the outer planets, the astronomer and storyteller Carl Sagan made a special and poignant request. He asked the mission team at NASA to turn the spacecraft's cameras around, one last time, and take a picture of Earth. From Voyager's incredible distance of 6 billion kilometers, Earth would be nothing more than a tiny point of light. But to Sagan, this perspective was everything. The engineers were hesitant at first. The image would have no scientific value, and pointing the camera so close to the sun risked damaging its sensors. But Sagan persisted, and in the end, they agreed. And so, Voyager turned its gaze homeward and captured one of the most profound and humbling images in human history. The picture that came back is not spectacular in the way a vibrant nebula or a majestic galaxy is. It is a grainy, simple photograph, filled with scattered rays of sunlight, an artifact of looking back at our brilliant star. And in one of those sunbeams, suspended in the vastness, is a single, tiny, almost imperceptible pixel of light. It is a pale blue dot. That is our home. That is us. On that single pixel, every human being who has ever lived has lived out their lives. On that tiny stage, all of our triumphs and our tragedies, all of our wars and our famines, all of our joys and our sorrows have taken place. Every king and every peasant, every creator and every destroyer of civilization, every mother and every father, every saint and every sinner in the history of our species lived there on a mote of dust suspended in a sunbeam. From this distant vantage point, the Earth seems so small, so insignificant. Our posturing, our imagined self-importance, the delusion that we have some privileged position in the universe, are all challenged by this single point of pale light. Our planet is a lonely speck in the great, enveloping cosmic dark. In all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. This perspective does more than just humble us. It unites us. From 6 billion kilometers away, the lines we draw on our maps, the borders we build between our nations, the divisions we imagine between our cultures and our beliefs, all of them vanish completely. They are revealed to be the invisible, imaginary constructs that they are. From space, the Earth is seen not as a collection of separate competing parts, but as it truly is, a single, whole, and deeply interconnected system. It is one biosphere. The atmosphere that carries the winds and the weather knows no boundaries. The great ocean currents that regulate our climate flow as one body of water, connecting every continent. The oxygen generated by the great forests of the Amazon is breathed by people on the other side of the world. The water we drink has been part of a continuous, planet-wide cycle of evaporation and rain for billions of years. We are not simply living on the Earth. We are the Earth. We are a thinking, feeling, conscious part of a single, living, planetary organism. And this small, blue world is our only home, the only one we have ever known. This distant image is like a family portrait that reminds us of our shared heritage and our shared responsibility to one another and to the beautiful, fragile home that we all share. This humbling view is the emotional core of a great intellectual journey that began centuries ago with a man named Copernicus, who first suggested that the Earth was not the center of the universe. This idea has since grown into a guiding principle of cosmology, the Copernican principle. It is the simple, yet profound, idea that our position in the cosmos is in no way special or privileged. The Earth is not the center of the solar system. Our sun is a perfectly ordinary star in a quiet, suburban spiral arm of our galaxy. Our galaxy is just one of hundreds of billions in the observable universe, and it is not located in any special central place. We are, in every measurable way, average. But to truly embrace this principle is not to feel a sense of loss, but to feel a sense of profound liberation and belonging. To not be the center of the universe is to be a part of it. We are not special observers looking in from a privileged position. We are made of the same stardust, governed by the same physical laws, and are participants in the same grand, cosmic story as everything else. And from that deep feeling of connection, a sense of tenderness and love for our tiny, fragile home naturally arises. It is our cradle, our ship, our one and only island of warmth and life in an immeasurably vast and lonely ocean. And as our long journey brings us back to this pale blue dot, we are filled with a quiet sense of gratitude for this precious, irreplaceable jewel, our home. To look back at our pale blue dot from the great, dark expanse is to feel our journey come full circle, to feel a quiet love for the small, warm place where our story began. We have traveled now through space and through time, from the familiar to the unimaginable, and in doing so, we have woven together a single, grand narrative of the cosmos. And perhaps the most peaceful and profound truth we have discovered is that of connection. We have learned that the universe is not a collection of disparate, separate things, but a single, coherent, and unified whole bound together by a set of simple and elegant physical laws that apply everywhere and at all times. The same force of gravity that holds the pen in your hand is the same force that binds the Milky Way and Andromeda in their slow, cosmic dance. The same process of nuclear fusion that lights our sun is the same process that forges the elements in the hearts of stars a billion light-years away. The same laws of thermodynamics that describe the cooling of a cup of tea also describe the unfolding of the entire universe towards its final, tranquil state. And the very atoms that make up our bodies, the carbon, the nitrogen, the oxygen, were themselves forged in the hearts of those ancient, distant stars. We are not just in the universe is in us. And to feel this deep, physical, and unbreakable connection is to find our true place within the cosmos, a place of peace and of perfect belonging. And yet, for all that we have learned, for all the beautiful stories that science can tell us, our journey must end where it began, in a state of quiet and gentle mystery. For science is not a destination. It is not a book filled with final answers. It is a process. It is a path. It is a way of asking deeper and more beautiful questions. For every profound discovery we have made, from the expansion of the universe to the existence of dark matter, we have uncovered a dozen new and even more profound questions. We have built a small, brightly lit island of knowledge in the middle of a vast and endless ocean of ignorance. And this is not a cause for anxiety or for fear. It is the very source of the universe's endless beauty and wonder. It is a promise that the story is never over. There will always be more to learn, more to discover, more to be amazed by. The universe is an endless story, a book with an infinite number of pages, and we have only just read the first few sentences. To find peace is to be comfortable on this shore, between the known and the unknown, to be grateful for the light we have, and to be in love with the magnificent, gentle darkness that surrounds it. The feeling that this journey has been designed to cultivate within you is that of awe. Awe is the emotion we feel when we are in the presence of something vast, something that transcends our ordinary frame of reference and challenges our understanding of the world. It is the feeling of looking up at a star-filled sky, of contemplating the vastness of geologic time, of trying to grasp the intricate complexity of the human brain. And this feeling is more than just a fleeting pleasure. It is a deeply restorative and healing experience. Studies have shown that moments of awe can make us feel less focused on our own small personal worries and more connected to the world and to the people around us. It can make us more generous, more humble, and more curious. The quiet contemplation of the cosmos is a gentle and powerful form of therapy, a way of placing our own lives and our own concerns into a grander, more peaceful context, allowing our anxieties to soften and dissolve into the vast, silent beauty of it all. And so, we arrive at the end of our journey for tonight. We have found that true peace lies in the gentle balance between knowledge and mystery. We know enough to feel at home in the universe, to feel our deep connection to the stardust and the cosmic web. And we know little enough to be filled with an endless, hopeful sense of wonder. To know and to not know, to be secure and to be curious, to be grounded and to be inspired. This is the beautiful duality of our human condition, suspended here on our pale blue dot. The great story of the universe continues to unfold, a story of which we are an inseparable, thinking and feeling part. And now, it is time for our own small story of this day to come to a gentle and peaceful close. Thank you for joining me on this long and quiet drift among the galaxies. I hope it has brought you a measure of peace and a sense of wonder. If a particular part of our story resonated with you, I would be so happy to read your thoughts in the comments below. Your presence and your reflections make this journey a shared one. For more peaceful stories like this one, please consider liking this video and subscribing to our channel. But for now, all that is left to do is to let go. Let the images and ideas of our journey dissolve into the soft background of your mind. Allow your body to feel heavy and your breath to be slow and easy. May your sleep be deep and peaceful, and may your dreams be filled with the silent, gentle light of a billion distant stars. Good night.